Welcome to this lecture, where we build on the foundation of algebra and dive into its practical applications, particularly in economics. As we explore key mathematical concepts, factors, fractions, ratios, and functions, you'll begin to see how these tools are essential for analyzing relationships and trends in economics. For example, what influences decisions such as setting wages or predicting consumption patterns? The mathematical relationships we'll discuss today are critical in understanding and solving real-world economic problems. Let's get started by exploring these essential concepts and how they connect to the economic decisions that impact businesses, governments, and consumers. So, let's dive in. Let's start with factors. Each part of a product is called a factor. For instance, in the term 6x, the factors are 6 and x. Why is this important? Because understanding factors helps us break down more complex problems into manageable parts. Imagine you're analyzing the relationship between labor hours and productivity. If 6x represents the total output, then 6 could signify a productivity constant and x the number of hours worked. Breaking this down allows you to see how output changes with hours worked. Now, let's dive into fractions, a fundamental tool that we encounter constantly in economics. Fractions represent parts of a whole, and understanding how to manipulate them is essential for modeling relationships such as cost per unit or income shares. Here's a simple example. When multiplying a fraction by a number or variable, you multiply the numerator by that number. For instance, x times 6y multiplied by z equals x times z divided by 6y. When multiplying two fractions, you multiply the numerators and the denominators separately. X divided by 5y multiplied by z divided by 3y equals x times z divided by 15y. Let's apply this to a real-world scenario. Imagine you're calculating the proportion of a country's GDP that's allocated to investment versus consumption. By using fractions, you can represent and easily compare these ratios, helping you to understand how different sectors contribute to the economy. Fractions make complex comparisons and calculations much simpler, especially when dealing with percentages and shares in economic analysis. When adding fractions, it's important to ensure the denominators match. For example, if we add 1/3 plus 1/3 equals 2/3. However, when the denominators are different, we need to adjust them. For example, if we add 1/3 plus 1/9, we first convert 1/3 into a fraction with a denominator of 9, so we have 3/9 plus 1/9 equals 4/9. In economics, you might encounter situations where you need to sum different tax rates or portions of a budget. Adjusting the denominators in this way ensures that you're making consistent and accurate comparisons, just like how we adjust the fractions here. This concept is crucial for simplifying complex financial calculations and comparing different economic values. Let's break down the explanation for the fraction manipulation rules, particularly focusing on the example provided.